Probability IB questions, problem 8. A really important thing to note here is that there is a typo where it says 30 right here. Well, that guy should be a 300. If you tried it out and it was very confusing, tried to fill this out, well, I apologize. I tried to make that announcement to everybody, but if you either came in late or weren't here when I handed out this worksheet, you might have missed that. So if you're watching this because it made absolutely no sense, well, there was a typo. This is what our chart should look like. So on your sheet, if you still have it, change that. I believe in y'all's ability to add, subtract, and the whatnots to complete this table. Part B, it says, using the table or otherwise, find the probability of a person over 30 voting for the Reds. Well, let's see. Look at this box where the person's over 30. We look at this box where the person voted for Reds. We see that right here, both boxes covered, so we know that there were 130 people over 30 who voted for Reds. We take 130, we divide it by our total population, which is 500, and we find that this is equal to 13 over 50. The next part asks us, in part C, says, given that a person is voting blue, find the probability of them being over 30. Again, this is a conditional probability question, and we can reword part C to make it sound like something that is a little more familiar. Say, find the probability of them being over 30 given that a person is voting blue. You should follow along on your sheet when I say that, just so that you see how I'm rewording this. If you get a question like this on the IB exam, it'll be important for you to understand what each of these means. So in part C, it says the probability that a person is over 30 given that they are voting blue. Well, we know from our formula that this is equal to the probability the person is over 30 and voting blue divided by the probability that a person is voting blue. There are two different ways to use this. We can use this equation and solve for this probability, or we can look at our chart, get another color to look at it, and say, all right, we are saying that we're given that this person is voting blue. So we can make a new sort of population or a new set, which I put in sort of fuchsia. Let's put it in blue since I already used a purple color. So it's in blue. How fitting. So this is our new set. Well, how many of these folks who voted blue are over 30? Again, we can look at that intersection between the over 30 box and the blue box, and we see that 170 people were over 30 who voted blue. That gives us 170 divided by 290. Now let's look at the conditional probability part. If y'all aren't interested in reviewing this again, there's your answer. But let's see if we can find it another way. Color code this. Say, all right, let's find the probability that someone's over 30 and voting blue. Well, we see up here, someone over 30 and voting blue, 170. So the number of people who were over 30 and voting blue is 170 divided by a total population, which again is 500. 170 divided by 500. Now we can find the probability, put this in a darker purple, of voting blue. It's right here. So the probability of voting blue is equal to, well, number of people who voted blue divided by the number of total people, which is 500. If we look up here, 290 people voted blue out of a total of 500. So we can use these two things that we found little scrolly that says, all right, let's plug them into our formula. So the probability of a person being over 30, given that they voted blue, is 170 divided by 500 divided by 290 divided by 500, which is equal to 170 divided by 290. We can easily reduce this to 17 over 29. Put that out there for you. Remember, there are a number of ways to show this. We can either show this in fraction form. We can also show this in a decimal form, or we can show it in percents. It's really up to your fancy and what you like and what makes sense to you the most, because decimals, fractions, and percents are all right, all correct ways of showing our answers in probability.